dramatically demonstrate the wide differences in thermal conductivity of various technical ceramics, we set up an experiment where we put standard size rods into a high heat on one end and ice on the other. First, we fabricated simple rods of several materials Insaco typically works with. Then also added similar rods of aluminum and steel for comparison's sake. Next, we placed a heating coil into a protective refractory block which serves to uniformly apply heat to one end of the rods. The other end of the rod will be placed on a block of ice right here. So we'll have a hot end and a cold end. As expected, many ceramics like quartz and zirconia are highly insulating and took quite a while to transmit enough energy to melt into the ice. But others, especially the CVD grade of silicon carbide, almost immediately transmitted enough heat to readily melt into the ice. In fact, the thermal conductivity of this technical ceramic exceeds that of aluminum metal. At slightly lower conductivity than aluminum is aluminum nitride, which in turn melted into the ice at a slightly slower pace. Aluminum oxide or alumina and its single crystal form of sapphire transmit at a lower rate, but still melted significantly. We do know some practical limitations on this experiment in that all the rods started out at somewhat higher temperature than the ice, so did show some melt during setup, even before the heater was turned on. But the dramatic melt of the CVD silicon carbide certainly illustrates its high thermal conductivity. Perhaps this dramatic experiment will generate new thinking as designers consider material options for their next project.